Hello, hello, Algebra 1 students, and welcome back to the fun part of Topic 8, the factoring portion. Last class could have been fairly brutal for guessing and checking to factor polynomials, but I have some good news for you. There's some sunshine over that hill. Today we begin the process on a different way to factor that will work every time, is technically easier. It just has a few more steps. There's actually only 2 steps, though, to do it. And today, strangely, we're going to learn the second step. Next class, we'll learn the first one. To begin, though, let's see if we can remember what we did last class. So there are 2 trinomials here. Your goal is to put these into factored form. Okay? Same thing with this guy over here. And then while you're doing that, your teacher is coming around to pass out packets of algebra tiles. As a reminder, you should have 6 of the x squareds, 10 of the green x's, and 25 of the 1's. So, good luck. Organize those tiles so we can quickly check to make sure you have the right amount. And then we are going to go ahead and start our journey into a factoring shortcut. Ready, set, all right, as before, I'm going to take you through how I would have done this, and you guys can check your work here. So with 4x squared, I know that there's going to be 2 options. Either, and I should zoom in here, apologies, either we are going to have 2x and 2x, or we're going to have 4x and 1x. Those are the only 2 ways we can multiply to make 4x squared. Next up is negative 3. Let's see, I think if I do 3 times 2, that's 6. And then 1. That's the only way you can do 3 and 1 here. And I think there's no way to make 6 and 2 into this invisible 1 here. So I think that one's probably out. Let's look at the 4x and x. I don't want to put a 3 here. That's going to make 12. That's way too big. I think this is going to be a 1 and a 3. In terms of what's negative and what's positive, I want a positive 1x, which means after I do both these multiplication problems, I want the positive 1 to be the bigger number. I think that's going to make this a positive 1. That gives me 4x, and this will give me a negative 3. And we're probably set here. I'll double check it, though, just in case. Right? This will give us 4x squared plus 4x minus 3x and minus 3. And I think you can see if you combine these together, you do get the correct bx, or middle term. Whew. All right, let's try one more. For this guy, this one's easier. We know that x times x is the only way that we can make x squared, so that's good. To make negative 3, well, the order here isn't going to matter. I know either it's going to be positive 1, negative 3, or negative 1, positive 3. Which one? Well, this is a positive, so I want the bigger number to be the positive. That means it's going to be a positive 3. Negative 1, positive 3, and let's check. X squared, positive 3x, negative 1x, and negative 3. Putting these together does make that b term. All right. So if you were able to do those 2, honestly, you're doing awesomely. However, there still is a reason to learn the method for the next couple days, and that's like if, for example, you were asked to factor something like 12x squared plus 7x minus 2, right? That is going to be a bad one, because now for 12x squared you have lots and lots of options. Even worse, if this one was something like 10, now there's like 5, 6, 12. There's like 24 different possibilities of how you can factor this. The method we're going to learn today will narrow it down so you don't have to guess and check anymore. So here we go. We have algebra tiles, and this will be one of the last times we have algebra tiles this unit. Sorry, I know some of you are sad and others are not sad at all. We are going to do this, though, because I think it provides a really, really good visual of why this shortcut works. So here we go. When we multiplied polynomials earlier in this unit, we visualized the factors as the lengths and widths of a rectangle. For example, when we did something like x plus 3 times x minus 1, right? And do this with me with your algebra tiles too, and you can draw it with me as well. We would do this x, whoops, that was not a great x. We would do this x on the outside, and then we'd do 3 1s. I'll just draw a big block here and split this into 1s. I am just on the struggle bus today. There we go. All right, and these are my positive ones here, right? And then we had an x minus 1, so here is our x up above, something like this, and then a minus 1, so we have to do this with a negative. So this was the outside, right? And you could put that on your paper if you wanted. You could say that this is like the x plus 3 on the outside and the x minus 1. Cool. To find the inside, we used dashed lines to go through and visualize the rectangle, and the answer to this multiplication will be the inside. So I'm going to go through and subdivide this here. Okay, and on the inside, we can see we'll have an x squared tile, like so. We will have positive times x will be an x and x and an x tile. So we can see these guys right here. Not too bad. And last but not least, we have this, which is a negative times all of these. So that means everything on this side is going to be negative. That gives me a negative x, negative 1, negative 1, negative 1. All right. There we go. Nothing too bad here, here, and here. All right. And then to get our final answer, we have x squared, which has no like terms. We have these 3 1s, which have no like terms, so negative 3. And then we have the x's, which do have like terms. And we can see here, I'll do this in purple, that this positive x and this negative x are going to cancel out. And so that's just going to leave me with 2 x's left inside. Right? In fact, this was the answer to our problem up above, or rather what we started with, right? X squared plus 2x minus 3. All right. That means then that our product, or the answer, actually represents the area of the rectangle. So if we're given a trinomial like this, and we have algebra tiles, it should be possible to take this trinomial and put those pieces together and make the area. So what I'm saying is you wouldn't be given this outside here, you would only be given the pieces on the inside. And notice with these pieces, we were able to make them into a perfect rectangle. So we're definitely going to be playing with puzzles today. Let's go ahead and see if we can try one. Okay? Given the trinomial x squared plus 3x plus 2, create a perfect rectangle with algebra tiles. Sketch that picture below. Then use your model to find the factors, the outsides, length and width of your area. We're also going to leave some space over here because I'm going to show you how to do the box or the lattice or the array method. It's really just focusing on this box. Now, to give you an idea of what we're looking at here, I actually have some algebra tiles as well. I have this set up right here. So they're telling us we are given x squared, 3 x's, and 2 1s. Go ahead with your group right now. Use those algebra tiles and please arrange them so that they make a perfect rectangle, right? A rectangle where you can see is exactly just like this yellow rectangle. There's going to be no gaps in it. Once you've done that, unpause the video. Shouldn't take you very long, and we'll discuss the rest. Ready, set, go. All right. Well, try as you might. Actually, I guess we should backtrack here. We really need to understand a couple things. Every time we've used algebra tiles, we've put the x squared on the upper left, and we've put the 1s on the lower right. And that's really important. If you start with that, the x tiles are going to fall into place. Because otherwise, if you start with the x squared and then you just put the 3 x's right here, you're going to have a bit of a problem. Because every single time that we've done this area model with algebra tiles, if you even think about what we did on the previous page, the x's end up getting split into 2 different parts, right? For example, on this picture, there are 3 x's that are underneath the x squared, and there's 1 x that's on the right side. So somehow you need to split apart those x squareds. So what I actually like to do is don't start with the x's, start with the x squared and the 1s. These ones always go in the same place, x squared, and then notice you can put the 1s here or here. This actually isn't going to make a difference. So for now, I'm just going to put them here. It's less turning for me. Can we see where the x's fill in then? So we've got an x, right? And we have another x. And then we're going to turn this and find this guy right here. Did we just build a perfect rectangle, or close enough for me? Yeah, we did. All right. Well, now let's figure out the outsides. And the outsides is really like working backwards, yeah? So the easiest part to do is to make this x squared. So to find the outside, I'm going to take this x and I'm going to just put it on the outside. I'm leaving a little gap just so I know it's the border. And I know the only way to make an x squared, a blue one, is to border it with two greens, right? A green times a green will make that blue x squared. So that's pretty easy. Then we have to ask ourselves what goes in these corners. Well, clearly in these spaces, there's only space for ones, right? So we have this, but then wait, is this going to be a positive one or a negative one? Well, working backwards, we'd ask ourselves positive x times what stays positive x? Well, that's going to be positive 1. There's no reds anywhere in here. I think that means that all the outsides will be yellows, not reds. And look, we have the outsides. So we are going to go ahead and quickly draw this one. I'm not going to draw them every time, but I am going to ask you guys to. You'll get pretty good at them, but I'm not going to draw them every time because it just takes me longer than it does for you guys. So we've got our inside first. So we had this x squared like so, and then we put two of these x's down here. We put one x over here, and then we had these two ones. That looks pretty good. Positive, positive. These x's were all positives as well, and the x squared was also positive. Great. Then, I'm going to do those dashed lines again. We found the outside. And again, you can continue those dashed lines to the outside if you want, just so you can see the extra spaces here. On the outside, we had an x and an x. We had the 1 and two more 1s over here, which means that the factored form of x squared plus 3x plus 2 is, let's do 1 outside, this is x plus 1 at the top, and over here this is x plus 2. Ta-da! We put that into factored form with no guess and check. All we had to do there was make a rectangle. Now, hopefully you've seen the bit of the flaw in this plan. The flaw in this plan is you have to have algebra tiles, or at least you have to be willing to draw them, which can get obnoxious, but it is a cool way to do it. Now, the nice part, though, is you don't need algebra tiles. So let's go back to our box method and think about what we did. Box method-wise, we are starting with the inside of the box. And there are two terms we know exactly from this x squared plus 3x plus 2. We know that x squared went in the upper left, and the two 1s went in the lower right. Notice instead of writing out two different ones, we put them all together. Then what did we do? Well, we took two of the x's and we put them in the lower left. And then we took a single x and we put it in the upper right. Now, and here's the important part, and this is why from 2 classes ago, when we did the greatest common factor, we talked about the box method. We need to find the greatest common factor of each row and column. So I'm going to fill in this row from these two first. Okay, I'm going to say, what do x squared and 1x have in common? Well, they certainly each have a 1. You could take a 1 if you want, but don't they also both have an x? Right? This has a single x. This actually has two x's, but I can factor out an x from both of those. And so I'm going to say they both have an x in common. That's equivalent to the x that I have over here. Then we can do the same thing up above. We can say, what do x squared and 2x both have that I can divide out or factor out from both of them? Well, they both have an x. All right. What about 2x and 2? What's their greatest common factor? Well, they both don't have an x, so we can't take that, but they do both have a 2. So I can divide out a 2 here. And then last but not least, and this one's a little bit weird, 1x and 2, it doesn't even look like they have a common factor. But every number has a common factor. They all can be divided by 1. Now, a little bit of a faster way to do this, just backtracking. You don't need to erase, but I'm going to do it this way for the rest of them because, again, it's faster. X squared is easy to make. Once you find that these have x in common, we multiply because x times what is x squared? Well, x times x is x squared. X times what is 1x? X times 1 is 1x. x times what is 2x, x times 2 is 2x, and then I call this last box the bonus box. We can check it to make sure we're right. Is 2 times 1 equal to 2? Yes, it is. And so my starting trinomial was x squared plus 3x plus 2. Can we see the 3x in the box here? And using the box, we were able to get factored form of x plus 2 times x plus 1. No guess and check. Okay, let's try one more. X squared minus 3x minus 4. So algebra tile wise, x squared minus 3x minus 4 should look something like this. Okay, you have these. Please go ahead and try to make these into a perfect rectangle. Ready, set, go. You're back already? Well, you might have found that this one was a little bit tough because I think however you arrange these, you are not going to be able to make this into a perfect rectangle, right? If I put the 3 x's right here, then I can fit 1, and then I can fit 2, 3 of these x's, but I don't have a space for a 4th. And you're like, oh, well, that's not even a perfect rectangle. There's a gap. So, Mr. Grant, you probably have to rotate one of these. Well, that's a good point. So I'm going to rotate one. But that's not a perfect rectangle because I have these extra x's right here, right? And that's kind of a weird rectangle with this little protrusion on the side. So what do we do? Well, this is the weird part about this method, and it's actually the part that I'm going to ignore for a lot of today. In fact, you can totally do this problem. However, in order to do this problem, okay, we are actually going to rewrite this negative 3x as, and this is very important, negative 4x and positive 1x. Now, would you agree? What happens if you do negative 4 plus 1? What is negative 4 plus 1? Well, negative 4 plus 1 is negative 3. Okay, so if I come back and look at this, I have negative 4x's and, I'm sorry, I have negative 3x's here. I'm going to go ahead and give myself negative 4x's. So here's negative 3, here's negative 4x's. And here is a plus 1. Check out what happens now. The negative x's will stay grouped together. You can either go on the bottom or the side. And the 1 will go over here. If you combine like terms, though, these x's cancel and you still have negative 3x. Then I'm going to finish off with my 1, and I bet you can see where this is going, 2, 3, and 4. Doesn't that now make a perfect rectangle? Yeah, it's pretty wild, huh? Right, so if you go through and make this, and this is the last one I'm going to draw just because, again, it's very slow for me. But if you go through and create this, you're good to go. And once you've done that, the rest is very easy. Okay, so let's get this done. We have our x squared here. Let's make sure we remember the whole process. Instead of negative 3x's, we actually have negative 4x's. So here's one, split it in half again. There are my negative x's right here. And here's my positive x. And again, remember, combining like terms, these two canceling will still leave you with negative 3x's. So even though I have more x's, when you combine them, it's actually the same. And then I had these negative 4 1's right here, like so. All right, so looking at that, now let's go ahead and, since we were able to make a perfect rectangle, let's find the outside. So outside-wise, not too bad. I'm just going to draw it. You guys should probably use your algebra tiles since you have them available, and I hope you already did. We, on the outside, have, of course, an x tile and another x. That's the only way to make x squared. And then we have to think, where are the positives, where are the negatives? Well, x times what makes it a positive? Well, I think x times a positive 1 would keep that positive. But then for the rest, a positive times what becomes a negative? Well, a positive times a negative becomes a negative. I think these last 4 all have to become negatives. So looking at this outside, this is x minus 4 up here is x plus 1. I think what that's telling us then is that x squared minus 3x minus 4 becomes x minus 4, second try, x minus 4 times x plus 1. This is the factored form for our trinomial. Box method wise, let's take a look too. We're going to go ahead and sketch in the box method of what we did with the algebra tiles. X squared was in the upper left, and I'm going to show you right now we're just doing the inside of the box, right? And we're taking this and putting it in the inside of the box. X squared minus 4. Upper left, lower right every time. Get used to it. Then from here, you'll notice that negative 3x doesn't actually fit into this box. There's only one term left and there's two spaces. So what do? Well, we split negative 3x into negative 4x's and positive 1x, just like that. Then we find the outsides. Okay, to find the outsides, we look to see what they have in common. I'll start with this one on the left. It doesn't really matter where you start, though. I like to start on the left or the top, and we say, okay, what do x squared and 1x have in common? And hopefully you said they both have an x. You're right. Once you find one greatest common factor, the rest all fall into place. X times what is x squared? X times x is x squared. We've done the box a million times, you know it. X times what is 1x? X times 1 is 1x. X times what is negative 4x? X times negative 4 is negative 4x. Bonus box time. Is negative 4 times 1 negative 4? Yep, it is. And so we have again seen that the inside of my box, x squared plus, we'll do plus 1x minus 4x minus 4, becomes the outside here. And the outside was x minus 4 times x plus 1. Ta-da! Now, I told you we're going to split negative 3x into negative 4 plus 1. What if I had told you we're going to split negative 3x into negative 5x plus 2x? Is that allowed? Well, sure, that still makes negative 3. What about if I said negative 6 and positive 3? Or what if I said negative 50x and positive 47x? That still makes negative 3. Hopefully the question you're asking is, would those work? And strangely, the answer is no. There is actually only one way that you can split negative 3x so that it makes a perfect rectangle. And that step is actually pretty tricky. And so for today, we're going to ignore that step. That's actually the first step out of the two I mentioned earlier. So if you want to factor your algebra tiles into a perfect rectangle, we are going to factor by what's known as grouping. Using this box method, the technical term is factoring by grouping. We're probably going to call it factoring using the box method, though, because it makes more sense to students. And really, it's called factoring by grouping your algebra tiles into a perfect rectangle. So here are the two steps. First, you have to figure out how to rearrange your algebra tiles so that you create a perfect rectangle. This will always take your equation from a trinomial, right? This is the trinomial we have up here, into a polynomial with 4 terms. 1 term, 2 term, 3 terms, 4 terms. And that's because the BX tiles, those long green tiles, will always get split into 2 different sides of the x squared tile. Now, there is only one way to do that for every trinomial that is factorable. And we're going to learn how to do that next class. What we're going to do today, though, is I'm actually going to tell you what these two are every single time. And so that way, instead of having to worry about how to split it, we're just going to practice how to factor once we know how to split it. So I'm just going to call that the mystery step for today, how to figure out the negative 4 and the 1. So what do you guys need to do today? Well, you guys need to be able to either take your algebra tiles and or the box and figure out the outsides. That's it. Okay, so this third page, go ahead and turn to it, has 4 problems where you're both going to do an algebra tile model and the box method. You guys need to actually do both of these each time. However, if you want to alternate with your partner who creates the algebra tile model, that's fine. But you definitely need to all get the box method for every problem, because the more you practice, the better you're going to get. Okay, so let's get to it. Here's our first problem. And I think once you get an idea of what you're supposed to be doing, you can totally work on ahead. In fact, I'm going to ask you to pause the video and work on ahead. If you finish all 4 of these, get your teacher's attention. They're going to check it. If it looks good, they're going to send you on to the last page, which is going to have you do the same thing, but without algebra tiles. In fact, when you finish this page and you call your teacher over, please have your algebra tiles sorted again. That's 6, 10, and 25, so we can just get those packed up right away. Okay, so example first. I would like you, please, to factor x squared plus x minus 1. Now, for algebra tiles, right, or 2x squared plus x minus 1. Algebra tile wise, I have these ready to go for you. 2x squared plus x minus 1. But try as you might, you're going to take these tiles and go, I don't know how to make this into a perfect rectangle. It doesn't work. And so underneath every single one, I'm going to give you the same equation, but written out with 4 terms. This one, if you do 2 minus 1, is still this x in the middle. It's still the exact same. And so you're going to start with these tiles, and then you're going to split the x term into negative 1x and plus 2. And notice every time I do that, I'm going to have positive 2x's and negative 1x now. Notice, though, that I'm adding 1 positive for every negative, because they cancel out. We're basically adding 0. Once you add in those terms, you should be able to, I think, very quickly take these, turn one of them, doesn't matter which way, and now you can make your perfect rectangle. So that is what you're going to draw on your algebra tile model. However, we do also need to find the outside, but we'll come back to that. So you're going to go ahead and draw your model, but you can see mine right there, so draw yours. And then you're also going to do the box method, but the box method is actually very easy to make this into a rectangle, because my 2x squareds go in the upper left, and negative 1 goes in the lower right. That's going to happen every time. Then you get your other x's. So based on my model, I put 2 x's at the bottom and negative 1x on the right. So 2x and negative 1x. Now, a question I get asked often is, does it matter which way you put those? And to answer it, I'm just going to show you the visual. Would this have mattered if I had put my x squareds this way and I had put my 2x's? Let's see if this will let me turn today. There we go. I had put my 2x's up above, my negative 1 here, and my negative 1x down at the bottom. Does that still make a perfect rectangle? And the answer is yes, it does. So if you switched these, if you put the negative 1x at the bottom and the positive 2 up here, you're fine. But the x's need to border the x squared tile. They have to be there. All right? So that's the first part. However, all that has done is taken the problem and put it in as an area or inside the box. The second part is finding the outside. So let's do the algebra tiles first. The outside, okay, and I'll just keep it this way for now, which is fine. It matches my box. The outside, we might want to start with this. We'd say, okay, to make an x squared tile, we need an x, and we of course need another x, I think. And the nice part is if you got a blue x squared tile, you almost always know it's going to be bordered by greens. I'll do one more green right here. There we go. Now we have a couple more spots to fill in. This gap on the upper right, the gap on the lower left. So on the upper right, we know it's going to be one of these 1 tiles. Positive times what keeps it positive? Well, a positive times a positive keeps it positive. So I know the top will have a positive 1. This lower left, though, positive times a negative is that's going to be a negative. All right, here we go. And I think my outside is going to be x plus 1 times x times 2x's minus 1. Now, let's double check to make sure that's right. And to do that, we're going to go back to our box method. Okay, box method wise, we're going to take a look at this, and we're going to say, where is there a greatest common factor? And I traditionally start on this left side. You can start anywhere you want. I look at these and say, what do these two have in common? Well, they certainly both have a 2, and they both have an x. They don't have x squared, they just have an x. Once you get the 2x, the rest should fall into place. 2x times what is 2x squared? Well, it needs an extra x. 2x times x is 2x squared. 2x times what keeps it 2x? That's a 1. X times what is negative 1x? Well, that's a negative 1. And bonus box, negative 1 times 1 is negative 1. Now, let's say you got this wrong. This is the right way to do it. Let's say you got it wrong. Let's say over here you thought that the greatest common factor of 2x squared and 2x was just x, right? They both have an x, cool. And you're not wrong in that they do both have an x, but we need the greatest common factor for this to work. Because x times what is 2x squared? Well, that's 2x. X times what is 2x? That's 2. And 2x times what is negative 1x? Ugh, that's weird. Now we're going to end up in fraction territory. And it's possible to do with fractions, but if you get fractions, that means there's a different way to factor this box. So you might run into trouble there if you don't pull out that greatest common factor. So here's our answer. And so what does this tell us? It tells us if you were asked to factor, just sliding back over here, if you were asked to factor 2x squared plus x minus 1, then it is 2x minus 1 and x plus 1, right? The outsides of the box. And you can see that this method is pretty easy. I mean, look at all the work we had to show. We put the original problem on the inside. We used greatest common factors to find the outside, and we were good. Was there any guess and check there? No, there wasn't. Could you have done this problem with guess and check? Yes, you could. So there are 3 more here. Try these other 3. If you do get stuck, you can always unpause and watch me do it. You'll want to make sure that both with the algebra tiles and with the box methods, you're getting the same answer. All right. Good luck. Ready, set, go. All right. You're back. I'm going to go ahead and do the algebra tile stuff first, and then I'll show you the box after. So we'll do algebra tile box, algebra tile box, algebra tile box. Okay, so algebra tile first, negative x squared 2x plus 3. I think I have this one prepared for you, negative x squared 2x plus 3. And they tell us on this one, we're actually, instead of thinking this is 2x, we're going to get 3x is minus 1. Same thing as 2x. So we're going to throw these x's down here. I have another green that's going to group together right here. This guy is going to spin. And again, you could have swapped the sides. You could have put the red on the bottom, the greens on the right. And then we, of course, have our friendly x's that fill in here. This always bugs me a little bit. They don't snap to, so it's not a perfect looking rectangle, but that's okay. All right, let's find the outsides. Now, you'll notice with this red x squared, the only way to make a red x squared is with a green and a red tile. X times negative x is negative x squared. I want to put the red tile so that it lines up with the other reds. Red and red is going to keep red. This one's going to be the green up here. Looks pretty good. Red times green is red. Red times what keeps it red? Well, a negative times a positive stays a negative. What about these down here? Well, we want to do a positive times something to stay positive. I think these all have to be positive 1s. 1, 2, and 3. There we go. All right. And so for an answer, we got x plus 1 and negative x plus 3. X plus 1, negative x plus 3. Okay, let's try this using the box here. Box-wise, we're going to go ahead and take our marvelous, I guess I should get the box first. We're going to take our trinomial here, negative x squared plus 2x plus 3, and start fitting it into the box. Negative x squared, positive 3. All we have left is 2x, but there's 2 spots left, so we use this guy over here, 3x and negative x. Again, it doesn't matter which spot you put those in. Let's figure out the outsides. Starting here, what do they have in common? Well, to me, it looks like they both have a negative and they both have an x. Negative x times what is negative x squared? Well, that's a positive x. Negative x times a positive x is negative x squared. Negative x times what stays negative x? That's a 1. X times 3 is 3x. And check our bonus box. Is 3 times 1 equal to 3? Yes, it is. So my factored form, negative x plus 3 and x plus 1. Ta-da! All right, 2 to go. 2x squared minus 5x plus 3. Okay, that's our next one over here. 2x squared minus 5x plus 3. Right? Try as you might, I think you're not going to be able to arrange these 5x's to get there. What do they tell us to do? We have to split it, negative 3x and negative 2x. Well, I think negative 2x will make the sense on the bottom then. And negative 3x is going to end up on my sides if your x squareds are arranged like this. They might not be, so you might have to do something a little different, but that's all right. So we have 1, and then of course 2 and 3. Love that. And then we've got the ones over here. 1, 2, and 3. Look at that rectangle. Ta-da! All right. Let's go ahead and see if this is going to work. Okay, I think everything looks fine here. So we have to find the outsides. Outside-wise, I know these are positives. I think these ones have to be greens. That looks pretty good. And this one also has to be a green, because that's the only way to make the blue ones, greens, yeah. And then to make a red, green times what turns into red? I think these ones have to be negative ones at the top. So this will be 2x minus 3 at the top. 2, 3. And then on the side, x times what will bring it a negative? Oh, that's a negative 1. And can you see our bonus box in the corner? Is a negative times a negative a positive? It is. That looks pretty good. I'm looking at x minus 1 and 2x minus 3. Let's do the box to confirm, though. All right, box-wise, we are starting with 2x squared minus 5x plus 3. All right, so we have 2x squared here and a positive 3. And then we have to split negative 5x. They told us how to do it. Negative 3 and negative 2. Negative 3x, negative 2x. And we start looking for like terms. Okay, because this is positive, I'm going to make sure these two sides up here stay positive. 2x squared and negative 2x, they both have a 2 and an x. 2x times 1 is 2x squared. 2x times x is 2x squared. This will be a negative 1. Can you see that? And x times negative 3 is negative 3x. Bonus box is negative 3 times negative 1, positive 3. Yes, it is. So factored form, 2x minus 3 and x minus 1. Last one, just to make sure you're getting the hang of it, 4x squared plus x minus 3 this time. All right, so let's close this off to my last one, 4x squared. So I'm going to start by hoping it arranges like this. I may have to switch things up, which is okay. And then they said plus x minus 3, but then they said, split that into 4x and 3x. Okay, now I'm seeing 3x there. I think this is probably not going to go the way I want it to do, but that's okay. So if we do this, we can do 1, 2, right, 3, and 4. Can you see already that this isn't going to work out, unfortunately? So I think instead we're going to have to go this way. Now I have space for 4 of these at the bottom. 1, this one is tricky, huh? 2, 3, and 4. That's going to bug me. Let's get it sitting in there decently. It's better. And then these guys are going to have to rotate, aren't they? Rotate, rotate, and rotate. Look at that. Then we have 1, 2, 3. And we check the 1s. There we go. The 3 1s are going to fit in just fine. So we have that elongated rectangle here. Yeah, instead of arranging the x squareds in a 2 by 2, you had to do a 4 by 1. Otherwise, it won't fit. And then to find the outsides, nothing too bad. I bet you can see it's an x with a 1, 1, 2, 3, 4 x's, and then minus 3 at the end. But to check that with the box, we have our box right here. And the nice part with doing the box is we didn't have to figure out how to arrange the x squared tiles. We just know there's going to be a 4x squared up here and a minus 3 at the end. Our mystery or our magical step, we know there's going to be a 4x and a negative 3x to keep it as 1x. Let's find the outsides. We're getting better at this. Now, I did say I usually start here. I'm not going to this time, and that's because I have a 4x squared and a 4x. That's really easy to see that they have something in common. They both have a 4 and both have an x. All right, 4x times what is 4x squared? Well, that's an x. 4x times 1 and x times negative 3. Bonus box works out. All right, final factored form, 4x minus 3 times x with a positive 1. All right, so hopefully you guys have gone through and packed up those algebra tiles, or you're on your way to doing it, and you can just listen while you're quietly, I know they're noisy, quietly packing up those algebra tiles. I already mentioned that you can do this in several different ways. I just wanted to show you that you'd get the same answer if you did the box in a different way. So keep on packing up those tiles. But if you did 4x squared with a minus 3 like this, and then put your negative 3x and your 4x, I think you still get the same answer. Now I'd start going left to right. This would be a 4x this time, and this would be an x, a 1, and a negative 3. Can you see that's still 4x minus 3 times x plus 1? However, if you decided to be really bold and you're like, I want to put x squared somewhere else, and you're like, I'm going to put the 4x squared over here, and then I'm going to put the 4x, the negative 3x, and the negative 3 like this, then you're in trouble. And you're in trouble because this wouldn't make a perfect rectangle. Every time we've made a perfect rectangle, the x's had to border, and I'll show you the border right here, had to border 4x squared. This guy must go there. So it doesn't really matter how you set up the box. Just tradition, we put the x squared on the upper left. You could do this. You could do 4x squared here and negative 3 here, and then your 4x and negative 3x. You could even go very weird, and you could put your 4x squared down here and negative 3 up here, and then a 4x and negative 3x. That's fine, but you need to realize that those x's must border the x squareds every time. We can see that with our algebra tiles. Okay, so the last part of today, this in-class practice, and this is just like your independent practice for tonight, this is that step 2. I'm telling you how to split up the b term. You just have to factor it. Okay, so I'm going to do one with you. You guys are going to do the rest, and then if you need, you can tune back in at the end to check your work. Okay, so here we go. We are going to put this into factored form, and so I know my final answer will have 2 sets of parentheses here. Let's go ahead and look at that box. Okay. We have 3x squared, negative 4, but then we have this 11x. I'm like, drat, there's 2 open spaces. Well, through the mystery step, I'm telling you what goes in the 2 open spaces, negative 1x and 12x. Okay, now this one's a little bit trickier, and here's the mistake I see a lot of people make. They look at this and go, 3 and 12, 12 divided by 3 is 4. And they're right. But remember what we did before? To find greatest common factors, we looked at these on our green factoring sheet. Yeah, that factoring sheet's still important today. And for 3 on your factoring sheet, there's only 2 factors. And 12 has a couple. It has 1 times 12, it has 2 times 6, and it has 3 times 4. Which is the common factor to both of these? Right? We don't talk about 1. Well, actually, we kind of do use 1 today. But the only common factor is 3. That is the number that you take out here. You factor out 3 from both of those because 3 goes into 3 and 3 goes into 12. So don't do the division. Do less. Just what number goes into both here, right? Okay, so for the number that goes into both, that's 3. But then also there is an x, right? The same way that we bordered the x term on the inside here, we're also always going to border the x squared with x's on the outside. Once you get one of them, try the rest. 3x times what is 3x squared? That's x. Okay, let's say you thought it was 4x though. Okay, if you thought this was 4x, you'd run into an issue here right away, right? 4x times what is 3x squared? I don't know, some weird decimal, right? So we'll just say 3x. 3x and x. 3x times 4 is 12x, and x times negative 1 is negative 1x. Bonus box, yeah, we're looking pretty good. My factored form, 3x minus 1 times x plus 4. And once again, no guess and check here, right? We put the 4 terms in, you use greatest common factor to find the outside, and we've factored. Okay? You could have used guess and check to get this answer. All right, now we finished problem 1, and at this point I did mention you can pause the video and move on. I'm actually going to backtrack there. Wait, because when we get to number 2, I think you're going to find that there's a typo on your paper unless you have the updated version and yours doesn't look exactly like this, and it's going to make problem 2 really difficult to do. So sit through me with problem 2 unless yours is already updated. Even if it's not, you might as well watch. You'll probably get something out of it, and then you can do the rest on your own. So let's go a little faster. We've got our marvelous box here. We know this will be 3x squared and a minus 4. Only have a 4x left. There's 2 spaces, so it's marvelously split into these 2 guys. We'll say 6x, negative 4x, and then we start filling in the insides, right? We say, okay, 3x squared and 6x. Maybe you get a little intimidated. Like, I'm not really getting that greatest common factor thing. Looks scary. Let's go ahead and work the other way. Well, if you work the other way, we'd look at 3x squared and negative 4x. 3 and negative 4 have nothing in common, but x squared and x at least have an x. Okay. Then we'd say x times what is 3x squared? X times 3x is 3x squared. And then you might realize, oh, I see. 3 and 6 have a 3 in common. We can divide that out. This will be negative 4. 3x times what is 6? That's 2. And then we check the bonus box and, oh. Negative 4 times 2 is not negative 4. Ruh-roh. If that happens, then usually what happened is one of 2 things. Option 1 is you made a mistake on one of your outside greatest common factors of your box. But option 2, and this will happen a lot next class, is these 2 terms up top are wrong. And in fact, in this case, one of them is wrong. This should actually be a negative 2x, not a negative 4x. So I'm going to change this to a negative 2x, and we're going to fix these last couple factors here. In fact, this 2 is still going to be good, but x times what's negative 2x? X times negative 2. And now I think the bonus box checks out. So we can go ahead and say that our factored form is 3x minus 2 times x plus 2. Hopefully I didn't make any more mistakes on this, but again, I actually kind of liked that because it showed us that we could catch our mistake just by looking at the bonus box as we finished. So there are 6 more of these to do. Put them inside the box, find the outsides, and you should be good to go. If you want to check at the very end, you can unpause, and I'll let you know if you did it right or not. And that is just about it for today. So good luck. Try them. Unpause if you need. Ready, set, go. All right, you're back for more fun. Well, let's go ahead and go through this. My computer's having a hard time. 8 years old and still kicking pretty well, but definitely slowing down a bit. Here we go. Okay, we need our box. We need the insides, 4x squared and 6. We split 11 into 2 terms, negative 8x, negative 3x. Okay, 4x squared and 8x, they certainly each have an x in common, so we'll put that x in there. And then they also can have, if you list out all the factors, their greatest common factor is a 4. 4x times what is 4x squared? Well, that's 4x times x. 4x times negative 2. Whoa, my computer finally caught up to us. And then x times negative 3. Okay, remember that that's a negative 2 because I'm going to go ahead and write my final answer down here. The screen may shift. We have 4x minus 3 and x minus 2 for our final answer. All right, problem 4. Zoom in. You can do this, computer. Hopefully by the end of this semester I'll have a newer computer, but that's a wish list thing, I think. 4x squared and minus 3. We split 4x into negative 2x and positive 6x. Like terms are going to be really important here. 4x squared and 2x, they each have a 2 in common and an x. 4x squared and 6x each have a 2 in common and an x. 2x times 2x, I'll do this in red. 2x times 2x is 4x squared. 2x times negative 1. 2x times 3. 3 times negative 1 is negative 3. We are looking good. I think we have our final answer of 2x with a positive 3 and 2x with a negative 1. This is pretty darn quick for factoring, right? If they ask you to factor instead of guessing and checking all the ways we did last class, find the middle, find the outsides. Woo! All right, here comes problem 5. For problem 5, we have that 6x squared. Those were ones we really struggled with at the end of last class. Because we're like, is 6x going to be 6x and 1x, or 3x and 2x, and 10 has all sorts of combos. But the box method will handle it no problem. 6x, negative 10, negative 5x, 12x. All right. 6x and negative 5x just have an x in common. That makes this 6x squared, which makes sense because 6 and 12 have a 6 in common. Negative 5. Positive 2. 2 times negative 5 is negative 10. Check, check, check. Final answer, 6x minus 5 times x plus 2. Okay, here's another 6xer, and we're no longer intimidated by that one because we know this box method now. We're getting great at it. Let's put these inside. 6x squared and a 6. Split negative 13x, negative 9x, negative 4x. And let's start finding that outside. 6 and negative 9 looks to me like we each have a 3 and an x in common. And just double checking, 6 and 4 do have 2 in common. Negative 3, negative 2, bonus box, checks out. All right. We end up with 3x minus 2 times 2x minus 3. 2 to go. Ooh, a 12x squared. We didn't even go through this one last class because, full disclosure, I hate guessing and checking on problems that have lots of factors, and 12 has 3 different options, right? 12 and 1, 6 and 2, 3 and 4, and then 8 has a bunch of different options. We're talking like minimum 24 guesses here. I don't want to do it, which is one of the very few times that I will actually use this box method. I don't use the box method every time. Guessing and checking is still usually faster. Unless there are lots of factors, then we do the box. Okay, 32x, negative 3x. What do they have in common? Well, 12 and 3 each have a 3 in common. And this one's a 4. And that checks out because 12 and 32 both have a 4 that goes into those. 4x times 8, 3x times negative 1. Negative 1 times 8 is negative 8. Sweet. Look how quickly we factored a potentially intimidating 12x squared trinomial. I put a 12. This should be an 8. Awkward. Sorry. Let's turn the 1 into an 8. Okay. Last one. Another 12x squared. And with a 21. Nope. Wouldn't have attempted it. But hello, box method. Negative 32 is getting split into negative 14x and negative 18x. Still don't know why we're splitting it that way. How do we figure that out? But let's figure out the outsides. 12x squared and 14x, they're right next to each other. They're both even. I think they both have a 2 and an x in common. And that's going to be a 6, which makes sense because 12 and 18 both have a 6 in common. Use that factoring sheet if you need to. This is negative 7. And 6 times negative 3. Negative 3, negative 7 do become 21. And so we end up with 6x minus 7 and 2x minus 3. Ta-da! So thank you for hanging out with me. Hopefully today was much less intimidating than last class. Next class, we're going to put everything together. We're going to understand how to perform that mystery step, and you guys will be well on your way to being the most successful factoring generation of Algebra 1 students of all time. Good luck.